Good afternoon, kids. This is Mr. Gonzalez, and for the kids who already have me, so they know who am I. For the kid that never had me or they just saw me in the building, you know who exactly. Like I said, who am I? This is going to be our second lesson of summer school. I posted one today that was only like a review stuff regarding rounding numbers. So that was basically for you just to practice what we learned at the beginning of the year. Since I know that the first day of summer school, a lot of kids don't register or they don't have the correct instructions. But now that you do, okay, we gotta start, working together. Okay, this is what we're going to do today. We're going to do real numbers, set of real numbers. And this is like an overview. I attach this to your worksheets so you can like print it or just download it so you can look at it and use it as a reference. Remember, real numbers involve all types of numbers. Okay? Now, the real numbers are divided into big groups. We have irrational numbers and we have rational numbers. You see this one? Rational numbers are all this big circle right here. Okay? Now, inside that group of rational numbers, we have integers, we have whole numbers, we have natural numbers, okay? And they are easy to work with, okay? But now we also have irrational numbers, which are, I would call them like ugly numbers. You see, anything that involves this pi symbol, pi is an irrational number, and anything that involves a number that is not a perfect square is also an irrational number. And you see here we have 1 over radical 2, even though 1 is a whole number, but radical 2 is not a whole number, it is not a perfect square. So that makes it already irrational. Here, radical 5 is not a perfect square either, and because it's negative, that doesn't matter. Because when you have like a square root, if you have, let's say for instance, the square root of 4, you will have positive 2 and negative 2. You will have two roots. So here, automatically, even if this is positive, it's still irrational because 5 is not a perfect square. We have also decimals that never ends, that it goes on forever and doesn't have any pattern. You can see this. It doesn't have any, neither one of the number repeats, okay? Repeats on a pattern. And radical 3 is another one that is not a perfect square. So I only want you to concentrate on these two, irrationals and rationals, okay? Because some of these numbers can be everything, all right? So just do as much as you can, all right? Like I said, use this on the lesson when you for your homework. And look, also I give you some examples here. So the difference: natural numbers are counting numbers. That means all positive numbers from 1 to infinity without the 0, because counting numbers means something that has value and 0 has no value. Whole numbers or natural numbers plus 0 are from 0 to positive infinity. Now we have integers. Integers are positive and negative whole numbers. That means that we can continue to the left, okay, to negative infinity, and we will form the set of integers. Okay, remember, whole numbers are only positive numbers, including 0. Well, positive whole numbers, right? And the counting numbers are positive whole numbers without the 0. Now you got the integers, you have rational numbers. Rational numbers can be written as a fraction. So if you have a fraction of two real numbers, two whole numbers, it's automatically a rational. If it's written as a decimal and it has an n, it's rational. If it's written as a decimal and it repeats like here, 0.3333, it is rational. If it's negative, even though this is integer, but it's also rational number because it's in the same group. All these numbers here are inside this big subset of real numbers. So remember, use this as a reference, and look, irrational numbers are numbers that can not be written as a fraction of two whole numbers, okay? So if you have a fraction With whole numbers like 2 over 3, that is rational. But if you have a fraction when one of the numbers is not perfect square, then it will be irrational. For instance, this one, 1 over radical 2. It's not the same as 1 over 2. Okay? So, I'm going to go to the lesson now, and I'm going to try to explain to you the best I can. But remember, you have this sheet on the attachments, okay? So you can either print it or you just like download it and look at it as a reference. So if you remember these two things, guys, you will be set, okay? So I know in the reference sheet, this on the back page is something like there is something like what is it? Absolute value. Don't worry about that for now, okay? So let's go into the lesson. Okay, remember, as I gave you this in class as a do now, as a warm-up, and I'm asking you, using this set that I'm giving you in the reference sheet, irrationals and rationals, label to which group these numbers belong, okay? It can be more than one group. Now, remember the first thing, they all real numbers, okay? All these are real, but we have to make sure if they're rational and irrational. And they also could be part of another group, all right? Okay, for instance, you know my definition. I have a fraction here of two whole numbers. 12 is a whole number, 18 is a whole number, so that's automatically rational, okay? Now, see what I mean? If you don't know that it's rational, okay, try to divide that, convert that to a decimal and see what happens. So I'm gonna divide 12 into 18 and I get 0.66666 that repeat. Look, this one over here, it turns to 7 because the calculator already rounded, okay? Because the 6 goes on forever. So if I convert this to decimal, that will give me 0.6666, okay? And because, according to my definition here, if a number repeats, all right, it's already rational, okay? So that is a rational number, all right. -5. -5, okay, is a rational number also because rational numbers are all whole numbers or integers. So this one over here, beside that is rational, is also integer because it's negative and it's a whole number, okay? So, but like I told you before, concentrate either on rational or irrational. Everything else, you know, is like an extra information for you. So, pi, from the very beginning, I know is irrational, okay? 5,564, okay? Remember, guys, this is automatically a rational number, okay? But also, because it's a positive whole number, it's an integer. And also, if you go back to here, right? Remember, if you go back to here, that also is integer, and because it's positive, it's also a whole number and a natural number. So that number has all the characteristics. It's rational, it's an integer because it's negative whole number. It's positive whole number. And this one is a whole number because it's positive and it's a counting number. So all this thing falls into that number. So that will be rational, it's an integer, it's a whole number. I'm going to use the symbol of number, and there is a natural number or counting number, okay? So any positive whole number, besides being rational, will have all these three characteristics. Now, the integer is not a whole number, okay? Because remember, whole numbers are all positive numbers, and it's not a counting number because it's also negative. Only positive whole numbers have all the characteristics. Now, radical 13, obviously, okay, is irrational because radical 13 is not a perfect square. But how would you know also that it's irrational? If you convert that to decimal, this is what you have to do. You're going to go to second, okay, x squared, and you're going to type 13, all right? Something like that. Exit out by clicking on the arrow button and do enter. And you see, you get 3.605551,275. That number goes into infinity. It doesn't end. Calculator only give you a chance to write 10 numbers. So because of that, because it doesn't end, it doesn't have any pattern, it's also irrational, okay? So if you want to convert this to decimal, we know that it's 3.605551275. But remember, that probably was a 4, and because the calculator doesn't hold more than 10 numbers, it will round them up. But you can definitely see that there is no pattern here, okay? You can say no pattern of repetition. Because even though the 5 repeats 3 times, but it breaks it down when you get to here, and you didn't begin with 5 either after the decimal point. So remember, in order to have a pattern, it's like a number that repeats itself. Like let's say 0.125, 0.125, 0.125 will be different because 125 is repeating forever. Or 0.66666, 0.33333, all right? Now this one, I know this one is irrational. I'm sorry, my bad. It's rational, sorry. My bad, guys, my bad. It's rational because this is a fraction, and 4 and 3 are whole numbers. So automatically, I know that is rational. Now, because it's rational, right? What else can it be? If you don't know that it's rational, what would you do? You will probably divide it, okay? And you convert it to decimal. We're going to have the negative because that's going to be negative no matter what. And if I divide 4 divided by 3, look what I got, okay? I got 1.3333333. So you see here, the 3 repeats until infinity. So that's why, if you don't know when the number is rational or irrational, just convert it to decimal. And if it does repeat, it's going to be rational. If it has an end, it's going to be rational, okay? So let's put this as a decimal, negative 1.333. And you know, when you get to that, you can just go like this. You can do that, or you can write negative 1.3 and just put the little bar on top, and that means that repeats forever. Okay, so remember, if you don't know automatically that's rational, convert it as a fraction. And when you, I'm sorry, convert it as a decimal. And when that becomes decimal, if the number and the decimal spot repeat forever, it's going to be rational. And if it doesn't repeat, it doesn't have a pattern like this one, it will be irrational. Okay? All right. So let's continue, all right, with the lesson here. And they ask you, find the value of each rounded to the nearest integer, okay, to the nearest integer. Guys, use a little common sense, okay? Remember the perfect square, okay? The perfect square, we have radical 1, radical 4, radical 9, radical 16, radical 25, radical 36, you know, and that goes on forever because those are perfect square. So look, if you think about it, right? When you get to here, radical 10, okay, radical 10 is between which two numbers here? Between radical 4 and radical 9, right? I'm sorry, my bad. Radical 9 and radical 16. So this one should be 3 and that should be 4, because remember the square root of a number has 2 roots. So positive 3 and positive 16. So what is the value? What do you think? Is negative 10 closer to radical 9 or radical 16? Obviously it's close to radical 9. So because they're asking you to write it to the nearest integer, no decimal, the first thing you have to do is put that in the calculator. I don't have to know because I know the properties, but if I write here second x squared, my bad. El botón azul, blue button, second x squared, and I type 10, all right? Let me just X that out and do enter. What do I get? I get 3.16222. This number is already irrational, okay? It's irrational because it doesn't have a is not a perfect square. But they're not asking me to identify what kind of number it is. They're asking me to round it to the nearest integer. Integer means the nearest whole number. So if you think here, that after the decimal point we have a 1, okay? And because 1 is less than 5, so they're going to stay the same. So the answer here, let me write it just the whole way so you see what I'm doing. So if I put on the calculator, I will get 3.162,277,77,66, and that goes, and that continues. I would probably round it, right? So to round it to the nearest integer or whole number, okay? So what do I have to do? I have to look at the unit value. The unit value here is 3, and because this one is close to, it's 1, which is less than 5, so the 3 is going to remain the same, so that should be the answer. But I knew that because I figured, well, radical 10 is closer to radical 9 than radical 16, so if radical 9 equals 3, that has to be 3. Now if it thinks this, then we go here. Let me just write one more here, okay? Let me write radical 49, because that should be 7, all right? Okay, look, if I have radical 49, so radical 50 between radical 36 and radical 49, right? You know this is already irrational, but that's not the case, okay? So because it is closer to radical 49, and this number here is 7, and that will be 6, because remember, 7 times 7 is 49, 6 times 6 is 36, that should be 5, 2, and 1. Remember, all those roots are 1 positive and 1 negative. So that means that just for me, because I know the rules, I know the answer is going to be 7. But let's say that you're not so sure about it. Just put it in the calculator. You go second x squared, type number 50, all right, and do enter. Then what do you get? 7.07106, okay? So look at this. Because this one, remember, this is the unit. When you round it to the whole number, you're supposed to round to the nearest unit, and the unit here is 7. So because after this decimal point, the first number is 0, and that's less than 5, so the 7 will remain the same, okay? But again, let me just write it for you so you know what I'm talking about. So if I put in the calculator, I will get 7.07106, and that goes on forever. So because this is my unit, and the one that is next to is 0, which is less than 5, so that remains the same. Now look at this one. 81.49. After this, okay, if I want to continue with my numbers, after this, I will get radical 64, then I will get radical 81, okay? Then will become radical 100, okay? I got to the hundreds, okay? So this one is going to be 8, that's going to be 9, is that going to be 10? Everybody knows that. So 81.49 is closer to radical 81 or radical 100? Obviously to radical 81. So that means that the square root of 81 is 9. So this number, if I round it, it will be 9. But then again, okay, if you don't know, go to the calculator and type, oh my God, again, okay, second x squared and type 81.49, I think it is. Yes. And just do enter. Look what you get. 9.027181177, and that goes on forever. So because this is the unit and the one next to it is 0, so that's how I know my answer is going to be 9. But remember, if you do not remember the rules, put that on the calculator and evaluate it, and that will give me 9.02718 and that goes on forever. And because this is my unit, okay, and the number next to is 0, so that means that will remain the same. The only way that it goes back up is when this one is 5 or greater than 5. Remember, that was the lesson that I just gave you. Remember reviewing the rounding? That's what I did that, okay? So let's continue with this one. Now here, they just want to make sure we know, okay, we're comparing two numbers. And some of the numbers are perfect square, some of the numbers are not. But if you don't know that this one is less than that, what do you have to do? The square root of 25 is 5. The square root of 64 is 8. So that means that 5 is less than 8. Therefore, radical 25 is less than radical 64. That's less than, remember, and the other one is greater than. Now, 4.5, so 4 divided by 5 is a fraction. I know that's going to be 0.8 because I'm going to put it in the calculator, right? So let me erase that. If I put 4 divided by 5, look what I got. 0.8, all right? And remember, any decimal that has an end is already rational. So to me, just for you to know, this is rational. This is irrational because 1.3 doesn't have, it's not a perfect square. This one is rational, and that's rational. Why? Because they both are perfect square. So when I calculate the perfect square, I get a whole number, right? Now this one, I don't know what is the value of square root of 1.3. But I know that the square root of 1, look, the square root of 1 is 1. So that has to be more than, right? That has to be a bigger number. So that's, so I already know that it's going to be less than. Okay, so also 0.8 is going to be less than that. But if you don't know that the square root of 1 is 1, then just put the whole thing in the calculator. So if I put second x squared, and I'm going to type 1.3, exit out, enter, what do I get? 1.1401, because that's irrational, right? So if you want to do that, it's fine. You should have a calculator. So that's 1.14017, and you know what? That's going to go on forever, because at some point the calculator always round them up. Every time you have a whole a rational number, the calculator rounds it because you only have the chance to write 10 digits, okay? No more than that. So you can clearly see that 0.8 is less than 1. Therefore, 4 over 5 is less than radical 1 over 3. 1.3. Pi. Okay, guys, don't get confused, because everybody thinks that pi is 3.14. No, 3.14 is an approximation that we ask you guys to use. But if you put the symbol of pi in the calculator, look what happened. So to put pi is the button that is pi is the button that's right here. Look, all right, above the division sign. I don't think you can see it either. Hold on. You see the button right here, that division sign. So it's this one, but it's the second function. So you have to hit the second button and this one to get p. Look, so I'm going to do my blue button second, and I'm going to do pi, and there's the symbol of pi. So now if you hit enter, look what happened. It gives you a crazy number, 3.1415 92654. That goes on forever. So you be very careful. So 1.14, I'm gonna write it down, 15, 92. Now you're gonna put some decimals, okay? Because that goes, that goes into the infinity. Now I'm gonna divide 19 divided by 6 to see how's that in decimals. And what do I get? Hold on. I get 3.16, okay? So 3.16, and you see that goes on forever. 6, 6. So you can just write it like that, okay? You can write it like that, or you can write 3.16 and put the bar on top of the 6. That means that the 6 repeats forever. You can see that $3.14 are less than $3.16, because you have to compare. After the decimal point, they both have 1. You see this 1 and 1, but the second digit after the decimal point, you have 4 and 6, so this one is greater. That means that this number is smaller than that. Therefore, pi is less than 19 over 6. All right? So let's do that one. Look, I don't have to do anything here. All these numbers, I don't know why, but they all become less than. Look at this. Just by looking at that, this is a negative number, and that's a positive number. So even though it's not a perfect square, this is not a perfect square, any negative number is less than any positive number, and even 0. So remember, the negative numbers, as far as they go from 0, okay, the less value they have. Negative numbers on the number line, the farther away from 0, the less value they have, okay? So, but let's say, for instance, you don't remember, all right? I know this is going to be rational because it's negative. It's not an integer because it's not a whole number. So if I divide 14 divided by 15, I get, look, 0.933333. So the 3 repeats forever. So I'm going to do that. I'm going to write negative 0.9 and 3 goes on forever. Like I say, I don't even have to do anything else because I know this is negative. But let's say if you don't know that, you're not aware that one is negative, one is positive, so you're probably going to evaluate it. So now you evaluate the square root of 0.8711. So I'm going to write second x squared, and I'm going to type 0.8711. 0 doesn't matter, okay? Because 0 to the left means nothing. If I do that, look what happened. It becomes 0.9333, okay? But be careful, okay? 0.933, because you say, oh, but the 3 is repeating here, but at some point you see that that pattern breaks down. So you have 3 3s and becomes 2, 7, 3, 8, 0, 9, and that goes on forever. Because I automatically know that this is irrational. How do I know it's irrational? Because it's not a perfect square, okay? So let's continue, let's move on, all right? We're almost finished, I think. All right. Order the numbers from least to greatest. Listen, you can put this in the calculator, all right? But you don't have to, you can use common sense. Look, this is a decimal, that's square root of 64. 64 is a perfect square, which is 8, all right? So already this one is bigger than that. Now this one, I don't even have to evaluate it because this is negative, so that has to be the smallest. And we ask you to write it from least to greatest, from the less value to the higher value. So my answer should be negative radical 121, which is my smallest, then 1.875, then radical 64. Let's say, for instance, also, you didn't know that that was a perfect square. You will put that in the calculator, and the square root of 121 is 11. But remember, because the negative is outside, you have to keep it. And now you can see better that this is the smallest, that's the middle term, and that will be the largest. And when you write the answer, you're going to use these numbers, the original numbers, not these ones, okay? Remember, we use the original numbers, not the one that I convert. Okay. This one is going to be a little tricky, but remember, we did this before on the back, okay? Remember, 4.5, look, I'm going to refresh your mind. Look, if you go back to the front here, okay, 4.5 is less than 1.3, so that means that 1.3 here is greater, okay? But if you don't remember, what you're going to do, you're going to put on the calculator. You know that 4 over 5, this one, is equivalent to 0.8. You know that. And that's 1 point what? Because I already did it. 1.14017, okay? 1.14, is it 0? Hold on. Yes. 0.17, and that goes on forever. Now this one, think about it, guys. This one is still going to be smaller than that because this is the square root of 1.3. This is the square root of 0.8711. But now I don't know if this one is bigger than that. So in this case, I have to evaluate this one. I have to because I'm not sure about that. So I'm going to go to the calculator. I'm going to put, oh, I already did. All right. It's 0.8711. We did it in the previous page. And that was what? That was 0.933, and it keeps going on, right? Now that you know, now you can compare them. This 1.9 is greater than that. So that means the smallest number here is going to be 4 over 5. Then the second one is going to be radical 0.8711. And the largest number is going to be 1.3. Okay? And this one here, now we'll go from greatest to least. Now I'm gonna go backwards. You know that 0.5, the symbol of pi is 3.145, and it goes on forever, all right? Now this one is negative because I think I mixed up here because I can't see if that's negative or positive. 15 over, it's negative 15 divided by 5.8, all right? So that's gonna be negative. So I know that's gonna be my smallest number because that's negative. I can see that from the very beginning. But if you're not sure, if you divide 15 divided by 5.8, 15 divided by 5.8, you'll get negative 5.862, and that goes on forever because I know that's actually that's supposed to be a rational number. So 5.86206.897, they gotta be somewhere here when the number is gonna start repeating. The pattern is gonna be, but you know what? I'm not asking you if it's rational or irrational. So the only thing that we're comparing, okay? So radical 10 is gonna be 3 and something. Radical 10 point something. So let me evaluate that, and that will give me 10.5625, and then do enter, and it gives me 3.25. Look, so that's a perfect square, you know, because it gives me a decimal and it has an n. That means that that's a perfect square. But again, we're not talking about, okay, guys, rationals or irrationals. So look, what we're going to do this is then write it from the greatest to the small one. We're going backwards. So the greatest here is 3.25. So that means that your first number is going to be 10.5625. Square root of 10.5625. Then pi. Then negative 15 over 5.8. All right. We're going to skip this one. We don't need to do this, okay? So, again, remember, guys, we did this lesson at the beginning of the year, so please do your best. This lesson, this homework is supposed to be by the end of tomorrow, okay? Because this is for Tuesday. So, if you can finish it, which you should be able to finish it, you only have 1 class or 2 classes, you can submit it the latest the following day. That's it, okay? No more time than that. So remember, when you do your homework, use the reference sheet, okay? That is provided on the lesson. Thank you, and I'll see you soon.